Welcome to my walkthrough for practice paper set 3 AQA paper 1. We're just going to have a quick look at some of the questions today that I think are going to cause the most difficulties or where the most common problems are. First questions that we're going to take a look at then is question 4. Not because it's a particularly difficult question, just that it's one that students often get wrong. Because the question is saying increase 50 by 200%, the one that students normally go for is 50 times by 2. This is actually incorrect, as if you're timesing something by 2, you're actually increasing it by 100%. So to increase 50 by 200%, we're going to be doing 50 times by 3. Question 5 is another question that students sometimes get wrong, and it's all to do with order of operations. So if I start with x over 3 minus 9 equals 12, the problem that students often make first is they try to multiply by 3, but I'm actually going to do it the correct way, which is adding 9 to both sides. So if I add 9 to both sides, I get x over 3 equals 21. I'm now going to multiply by 3, so I would get x equals 63. The next question that we're going to take a look at is question 8, and it's saying that here are the 4th and 5th terms of a Fibonacci type sequence. Now, a Fibonacci type sequence, you get the next term by adding the two previous terms. So to get the term that's before 28, I need to do 43 take away 28, which is 15. The term before that then, I'm going to do 28 take away 15, which is 13. And to show that the first term is 2, I need to do 15 take away 13, which equals 2. A good idea is to write these at the top of your page so that when you're coming back to check later on, you can see what you've done. 8b is a question again using Fibonacci sequences. This time it's using A and B instead of numbers. We can look at it the same sort of way. So really here what we're looking at is A plus something equals B. So that means that A's disappeared. So to get A to disappear, we need a minus A, and to get B we need a B. So the second term is B minus A. You can then go ahead and find the 4th term, because the 4th term is going to be our second term, which is B minus A plus B, which is 2B minus A. Our 5th term then is the 3rd term plus the 4th term, so we've got B plus 2B minus A, which is 3B minus A. Question 9 gives us a method by Noah for working out the base of a right-angled triangle. He's using Pythagoras' theorem, and he gives us with this example that 10 squared equals 100, 6 squared equals 36, 100 take away 36 is 64, and the base is the square root of 64. It's then asking us to tick the correct statement. So the method will always give an answer that's a whole number, sometimes give an answer that's a whole number, and the method will never give us an answer which is a whole number. So if we look at the square root of 64, the square root of 64 is 8. So we can rule this bottom one out straight away. It is definitely going to give us a whole number. Can we think of any other reason though, or any other way that it would give us a number that's not whole? If we go ahead and try and sketch a triangle, if we said that this side was 3 and this side was 2, then using Noah's method we'd do 3 squared take away 2 squared, which is 9 take away 4. We would then have to square root this, so we've got 5, the square root of 5, and the square root of 5 is not a whole number. So therefore we've got a method that will sometimes give us a whole number and sometimes give us a number that's not a whole number. Question 12 is quite tricky, 2 one-mark questions. So the first part is asking us to find out the value of A when x equals minus 1. So I'm going to go ahead and sub minus 1 into the equation that it gives us. And when I work these brackets out, I've got minus 1 minus 4, which is minus 5. And I'm multiplying that by minus 1 plus 3, which is 2. And this is all over minus 1, which is minus 2, multiplied by minus 1, which is 2, which means we've got minus 10 over 2, which is minus 5. Part B is giving us some limits of x and asking us whether whether a is always going to be positive, 0, negative, or could be positive or 0. The tricky part here is that realising if x is going to be less than 4, then the top part of the fraction, the numerator of the fraction, is always going to give a negative number. And if it's greater than 2, then the bottom part of the fraction is always going to give us a positive number. So if we have a negative divided by a positive, a is always going to be negative. I've put question 14 in here because estimation is something that students always seem to struggle with. Remember, when we're estimating, it's trying to make something easy. So I'm going to change 19.4 into 20 because I can square 20 quite easy. Then I'm going to add on 30 times by the square root, and instead of the square root of 104, because I can't find that easily, I'm going to times that by the square root of 100. So I've got 20 squared, which is 400. Then I'm going to add on 30 times by the square root of 100, which is 10. So 400 plus 300, which is 700. Question 15 is another tricky 1-mark question. What we need to realise is that 2x squared plus 1 over x can be rewritten as 2x squared over x plus 1 over x. So that means we've got 2x squared over x, which simplifies to 2x, and we're adding on 1 over x, which can't be simplified. So the answer is 2x plus 1 over x. Question 16 is about recognising our trig graphs. Now, y equals cos x. Some key facts there: it starts at 1 and intercepts the x-axis at 90. So looking at our graphs, that means it has to be graph A. Graph B is actually sine x. Graph C is minus cos x. And graph D is minus sine x. So just being able to recognise those properties can really help on these quick 1-mark questions. Question 17 is having a look at a proportion. So it's telling you in the question that Naz buys a fridge from a shop for £189. The cost of delivery is proportional to the distance from the shop, and that for every 15 miles the cost is £9. So I'm going to start off by figuring out how much it costs for delivery for 1 mile. So 1 mile would be 9 over 15, which simplifies to 3 over 5. 3 over 5 is a fraction that we should recognise, so that is 0.6. So that means that each mile costs 60p. To work out the cost to Naz's house, then, we need to do 60p times by 24. Now I'm going to try and make this a little bit easier. I'm going to do 60 times by 12 times by 2, because 12 times 2 is the same as 24. So 60 times by 12 is 720. I then need to times that by 2, which is 1,440. If we put this into pounds, then that means that it costs for the delivery £14.40. It says in the question that Naz's item, Naz's fridge, costs £189. So I need to do 189 plus 1440, which gives me a total of £203.40. So yes, it does cost more than £200. Question 18 gives us the graph of y equals 2x, and the question says that by drawing the graph y equals 3x squared minus 4 on the grid, work out approximate solutions to 3x squared minus 4 equals 2x. So it does tell us that we need to draw this graph. So the first thing that I'm going to do is make a table of values that I can sub in to find out my coordinates that's going to help me plot this graph. So as the graph goes from -2 to 4, I'm going to use these values to figure out my y coordinates. So the first part, then I've got to do minus 2 squared, which is 4, times by 3, which is 12, and then I'm going to take away the 4 to get 8. Then I'm going to do minus 1 squared, which is 1, times by 3, which is 3, and then take away 4, which is minus 1. 0 squared is 0, times by 3 is still 0, take away 4, so we've got minus 4. 1 squared is 1, times by 3 is 3, take away 4, minus 1. 2 squared is 4, times by 3 is 12, take away 4, gives us 8. 3 squared is 9, times by 3 is 27, take away 4 is 23. And 4 squared is 16, times by 3 is 48, and take away 4 is 44. Going to go ahead and plot these points now. So I've got minus 2, 8. Minus 1, 1. 0, minus 4. 1, minus 1. 2, 8. And that's the last one that we can actually plot. I'm now going to sketch this graph. I'm going to draw this graph, sorry. Try to make sure that your curve is smooth. The final part of the question then is saying work out approximate solutions to 3x squared minus 4 equals 2x. So that's where the two graphs intersect. So we're looking at here and here. And then we're going to look at the x values where those intersect. So I've got 1.5 and minus 0.95. So 1.5 and minus 0.95. Now you are allowed some leeway with this because it's only an approximate solution. So if you've got slightly different answers from your graph, then it doesn't matter too much. Question 19 is all about working with surds. So we've got the square root of 2 to the power of 4. So that means I'm doing root 2 times by root 2 times by root 2 times by root 2. So root 2 times root 2 is 2, and I'm timesing that by root 2 times root 2, which is 2. So I've got 2 times 2, which is 4. 19b is expecting me to expand and simplify. So I've got root 2 plus 3, and that is being multiplied by root 2 plus 3. So root 2 times by root 2 is 2. Root 2 times by 3 is plus 3 root 2. 3 times by root 2 here is another plus 3 root 2. And then I've finally got 3 times by 3 to give me plus 9. So I can simplify this by saying 2 plus 9 is 11. And 3 root 2 plus 3 root 2 is 6 root 2. Question 21 is looking at the area of a non-right angled triangle and the area of a rectangle. So it tells us that area ABE, so that's the triangle, equals the area BCDE, which is the rectangle. It also tells us that BC is 2 centimeters shorter than BE. So I don't know what BE is at the moment, so I'm going to call this X. As B is 2 centimeters shorter, then BC is X minus 2. To find the area of a non-right angled triangle, then we're going to do a half times by A, which I'm going to say is 10 centimeters, times by B, which is BE, so we're going to say that that's X, and times by sine of the angle, which is sine 30. Now sine 30 is a half, so I'm doing a half times 10, which is 5, and I'm timesing that by X, so I've got a half times by 5x, which is 5x over 2. If I look at the rectangle, I've just got the area of that, which is x multiplied by x minus 2, so I'm going to go ahead and expand that. So that is x squared minus 2x. Now it does say that the two areas are equal to each other, so I've got 5x over 2 equals x squared minus 2x. If I times both sides by 2, I get 5x equals 2x squared minus 4x. If I then make this equal to 0, I get 2x squared minus 9x equals 0. I can then go ahead and factorise. So I've got x bracket 2x minus 9 equals 0. This means that either x equals 0 or x equals 4.5. Now, as we can't have a side length of 0, x must equal 4.5. Question 22 is asking me to estimate the number of students who revise for less than 45 minutes. In this case, I need to find out how many people are represented by each bar. So to do this, I need to multiply the frequency density by the width of that bar. So on the first one, I'm going to do 0.8 times by 10, which is 8. For this second one, I'm going to do 1.6 times by 20, which is 32. And the next one I'm going to do 2.2 times by 10, which gives me 22. And in the last bar, I'm only looking up to 45. So I'm doing this part here. So I'm going to do 2 times by the 5, which gives me 10. I then just need to go ahead and add those numbers up. So 8 plus 32 plus 22 plus 10, which gives me an answer of 72. Question 23 is asking you to do some work with surds. So I'm going to start with the first part, 5 over root 3, and I'm going to go ahead and rationalise the denominator straight away. So that means I want to get rid of the root 3. So I'm going to do that by timesing by root 3 over root 3 to give 5 root 3 over 3. The second part, root of 6 3/4. Well, I'm going to turn this straight into an improper fraction, so I need to do 6 times 4, which is 24. Add on the 3 to get 27 over 4, and I want the square root of that. I can simplify this further by splitting it into the square root of 27 over the square root of 4, which means I'm looking at the square root of 27 over 2. Now, the root of 27 can be simplified into root 9 times by root 3, still over 2, which means that this is 3 root 3 over 2. To subtract these fractions, then I've got 5 root 3 over 3, take away 3 root 3 over 2. I need to make the denominators the same, so I'm going to make these over 6. I did that by multiplying the first fraction by 2, so I've got 10 root 3, and multiplying the second fraction by 3, so I've got 9 root 3, which means I've got 1 root 3 over 6, or just root 3 over 6. Question 25 is making sure that you understand Venn diagrams and the probabilities that go with those. So the first part is asking you to work out the probability that the student takes art. Now, the number of people that take art is represented in this part of the Venn diagram here. So I've got 14 and 25. So I need to add those together, which is 39. And there are 295 people altogether. So the probability that a student picks art is 39 over 295. The second part of the question is saying that one student who takes geography is chosen at random. Work out the probability that the student also takes art. So the students that take geography are these here. So we've got 14 plus 29, which is 43 students altogether. And the students who take art as well are these people in the middle. So we've got 14 out of the 43 students. Question 25C is a more complex Venn diagram. So it says in the question that 1/2 of the students who take history also take English. So if 1/2 of the students who take history also take English is X, then that means there must be X number of students that just take history. The number who take English is twice the number who take history. Well, there's 2x who take history, so there must be 4x that take English, but we've already got this x in the middle, which means 3x people only take English. The question then asks us to work out the value of x. So that is x plus 3x plus the 125 who don't take either equals the total amount of students, and the total amount of students is given to us in the question at the top, which is 295. We therefore have 5x plus 125 equals 295. I'm going to subtract the 125 from both sides to get 5x equals 170. I then divide both sides by 5 to get x equals 34. Question 26 is having a look at the equations of circles with tangents, and the first part of question 26 is saying to show that the coordinates of B are 0, minus 5. Now it tells us in the question that x squared plus y squared equals 25. Now this 25 at the end is the radius squared, so the radius must therefore be the square root of 25, which is 5. So because the radius here is 5, the coordinates of B must be 0, minus 5, and a perfect explanation is just that the radius equals 5. The second part of the question is saying to give a reason why PA equals PB. So PA equals PB. Now in the question, again, it does tell us that PA and PB are tangents, and because tangents from the same point are equal, that is a perfect explanation. So tangents to a circle from the same point are equal. That's the end of the walkthrough for this paper. I hope it helped. Keep revising hard for your exams in the summer, and good luck.